Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2 Decision Making Theory class with team members Reza, Novita, Sari, Atika, Putri, Dianti, and Andika Ade Setiawan. Also with the lecturer Miss Erni Hendrawati. In this presentation, we will talk about network models, which covers three techniques of network models. They are minimal spanning tree technique, maximal flow technique, and shortest route technique. My name is Reza Novita Sari, and I will present the first material. The minimal spanning tree technique. The minimal spanning tree technique determines a path through a network that connects all the points while minimizing the total distance. There are some steps that we need to understand in using minimal spanning tree technique. The first one, select any node in the network. Second, connect this node to the nearest node that minimizes the total distance. Third, considering all the nodes that are now connected, find and connect the nearest node that is not connected. If there is a tie, select one arbitrarily. A tie suggests there may be more than one optimal solution. Fourth, repeat the third step until all nodes are connected. For an example, the Lauderdale Construction Company is developing a housing project. They want to determine the least expensive way to provide water and power to each house. There are 8 houses in the project, and the distance between them is later shown in the figure. This is the figure for Lauderdale Construction. So, how do we use minimal spanning tree technique for this figure? Firstly, start by arbitrarily selecting node 1. The nearest node is node 3, at a distance of 2, and we connect those nodes. Considering nodes 1 and 3, we look for the next nearest node. Take a look at node 4, the closest to node 3. Then we connect those nodes. Now we look for the nearest unconnected node to node 1, 3, and 4. This is either node 2 or node 6. We pick node 2 and connect it to node 3. Following this same process, we connect from node 2 to node 5. Then we connect node 3 to node 6. Node 6 will connect to node 8. The last connection to be made is node 8 to node 7. The total distance is found by adding up the distances in the arcs used in the spanning tree, that is 16. Next, the second technique, the maximal flow technique. The maximal flow technique allows us to determine the maximum amount of a material that can flow through a network. For an example, Waukesha, Wisconsin is in the process of developing a road system for the downtown area. They want to determine the maximum number of cars that can flow through the town from the west to east. The road network is later shown in the figure. The numbers by the nodes indicate the number of cars that can flow from the node.
Well, continue to the next materials from Andika Ade Setiawan about maximal flow technique. Fourth step of the maximal flow technique. The third one, for each node on this path, decrease the flow capacity in the direction of flow by the amount C. For each node on the path, increase the flow capacity in the reverse direction by the amount C. But the fourth one, repeat these steps until an increase in flow is no longer possible. And talking about the maximal flow technique, we start by arbitrarily picking the path 1 to 6, which is at the top of the network. The maximum flow is 2 units from node 2 to node 6. The path capacity is adjusted by adding 2 to the westbound flows and subtracting 2 from the eastbound flows. The result is the new path in figure 12.7, which show the new relative capacity of the path at this stage. This is that we mean by the explanation previous slide. There are no more paths from nodes 1 to 6 with unused capacity, so this represents final iterations. The maximum flow through this network is 500 cars. For the path 1 to 6 to 100, 1 to 4, 6, 100, 1, 3, 5, 6, 200, and the total is 500. The shortest route technique. The shortest route technique finds how a person or item can travel from one location to another while minimizing the total distance traveled. It finds the shortest route to a series of destinations. Ray designs transport beds, chairs, and other furniture from the factory to the warehouse. They would like to find a road with the shortest distance. The road network is shown in figure 12.10. The plane 1 to the 2 to the midpoint 2, 3, 4, 5, and 6, and the warehouse on the 6th point. Steps: first, find the nearest node to the origin. Put the distance in a box by the node. Find the next nearest node to the origin and put the distance in a box by the node. Several paths may have to be checked to find the nearest node. Repeat this process until you have gone through the entire network. The last distance at the ending node will be distance of the shortest route itself. Like this one. And 1, 2, 3. Then you can go to 5. After that, directly go to 6.
My name is Atika and I will try to explain the example of the use of POM-QM in networking models. The example will be divided into two. The first one is single time estimate and the second one is triple time estimate. So let's just move to the first example. As we could see on the screen, let's say that company XYZ wants to make a project in which the company must to develop all of the activities A to H to manifest the project. Since we know that networking models being used to help in the preparations of project schedule and monitor of activities that must be run in separate sequence, PERT is very useful to improve efficiency in implementing projects, even may be used to monitoring the implementations of office administrations. So the first steps that we need to do is open POM-QM and click Project Management, then choose Single Time Estimate. After that, you will see this on your screen. Then you can change the number of activities and click OK. After you see these tables, you can simply input all of the data and solve the problem. Then you can see the solutions for your problems. You can also see the chart by choosing the options Solutions, then click the sub chart and see the chart. As we can see on the screen, there are several red lines. Those are critical paths, which could be defined as the time needed to complete the longest activity, where this path is the time of completing all of the activities on manifesting a project. So the time needed will be 3 plus 4 plus 5 plus 4 plus 3 equals to 17 days to make this project. So we already finished the first example. So let's just move to the second example. Triple time estimate. In this, we will find optimistic, realistic, and pessimistic time. Optimistic time with proxy O could be defined as the time of activity if all of the activities run without delays. For realistic time with proxy R is a time of activity that occurs when the activity is carried out in normal conditions and certain acceptable delays. Meanwhile, for the pessimistic time with proxy P is a time of activities that occur when obstacles and delays that exceed their expectations. So the first step is to open POM-QM and click Project Management, then choose the triple time estimate. Then you will see this on your screen, and you need to input the number of activities and click OK. Then you can simply input the data and solve the problem. You can also easily see the chart, and as we can see on the screen, the critical path is B to E, which has the time 7 plus 1, 9 days.
The implication network models in management. First, a network is drawn as a diagram, which literally provides a picture of the system under analysis. This enables a manager to visually interpret the system and thus enhances the manager's understanding. Second, a large number of real-life systems can be modeled as networks, which are relatively easy to convince and construct.
Okay, that's all from our group. If you have no questions of this technique and this material, please write down the question.